let us now discuss balancing of redox reactions. This is lecture number 3. Now discuss methods of balancing redox reactions. Answer is we have two methods. Number one is oxidation number method. Second is ion electron method. Or half reaction method. Now in both of the methods we have some rules. For example, first of all we discuss the oxidation number method of balancing the redox reaction. What are the rules for it? First of all, write skeletal redox reaction. First of all, we are writing the skeletal redox reaction in terms of symbols and formulas of different reactants and products. Then second rule will be identify or write oxidation number of each atom above its symbol. And total oxidation number below its symbol. So second step will be write the oxidation number of different atoms or ions above their symbols and total oxidation number below the symbol of those atoms or ions. Then identify those atoms whose oxidation number changes. Some of the atom might be suffering deficit in the oxidation number, some of them might be having excess of oxidation number. Now calculate the total increase and decrease of oxidation number. Fourth point will be how much total charge has increased or how much total charge has decreased. Then after doing this, equate the decrease in oxidation number with increase of oxidation number. They should be equal. 5 electron lost, 5 must be gained. So we have to equate the charges by multiplying with suitable integers. We will balance all those loss and gain of electrons. Then balance the other atom, balance the equation. With respect to all other atoms except hydrogen and oxygen, they are to be balanced in the last. Finally, balance hydrogen and oxygen, and then for balancing oxygen, add water molecules to the deficient side. Now balancing of oxygen, to balance oxygen and water equal to the oxygen deficiency. If two oxygen are deficient on one side, add two water molecules on that side. Then balancing of hydrogen in the acidic medium is done by adding H positive ions to the hydrogen deficient side and water to the other side. In acidic medium, balance hydrogen by adding H positive ions to hydrogen deficient site and water to other side. In basic medium, the reaction when taking place in the presence of base, in such cases add water to the hydrogen deficient side and OH ion to other side. So this will be our balanced equation. Now after going through these rules, let us balance some equation. We take this equation, Zn combines with HCl to give you ZnCl2 plus hydrogen. How to balance? Oxidation number of zinc is 0 here, hydrogen plus 1, chlorine minus 1. Here it is 0, both atoms are of same element, it is minus 1, it is plus 2. Total oxidation number plus 1, minus 1, plus 2, minus 2, it is 0. Now if we say oxidation number of zinc has increased by 2 units, and in case of hydrogen, oxidation number decreases by 2 hydrogens. For one hydrogen it decreases by 1. In order to balance hydrogen, multiply HCl by 2. Reaction was not taking place in acidic or basic medium, so that step is not used here. So this is a balancing of a redox reaction in terms of oxidation number method, and similarly we can balance other reactions. For example, we have a reaction MnO4 negative combined with H positive in the presence of your oxalate ion or ferrous ions. It is giving you Fe3 positive, Mn2 positive and 4 water here. Now this equation has to be balanced. First of all, our step was to write the skeletal redox reaction, that is written here. MnO4 negative, this is our redox reaction. Now what to do here? Write oxidation number of all the species. It is plus 7 lower side, minus 8, minus 7 on oxygen. So in this case plus 2, plus 1 plus 2, hydrogen is plus 1, total plus 2, plus 1 minus 2 minus 2, iron is plus 3. So if we move from iron plus 2 to plus 3, oxidation number increases by 1, and in this case oxidation number decreases by 5. So in order to balance the oxidation number, we multiply iron by 5. Now charges are balanced. Now we have to balance the other atom. We have 5 iron, 5 iron. We have oxygen, 1 air, air we were having 4 oxygen. So multiply water by 4. In doing so, we have 8 protons here. If we see, this equation is now balanced. Reaction was in acidic medium. We added H positive ion to hydrogen deficient side and water to other side. So this is our balanced equation by oxidation number method. Then we come to the second method, that is ion electron method or half reaction method of balancing the redox reaction. First rule is same as we saw in case of the oxidation number method. Write skeletal redox reaction. Second is write the oxidation number of each species above its symbol and total oxidation number below its symbol. Third, identify the oxidation half reaction, the species which is showing decrease in oxidation number, that reaction, and then identify the reduction half reaction, the species which is showing the decrease in oxidation number. Then two reactions, they are splitted separately and are balanced separately, and then added together to get the balanced redox reaction. Balancing of hydrogen and balancing of oxygen is same as we done in the previous case. For balancing of oxygen in the acidic medium, balance hydrogen by adding H positive ion to the hydrogen deficient side and water to the other side. But in basic medium, add water to the hydrogen deficient side and OH ion to the other side. So this is balancing of hydrogen. And in the acidic and basic medium, for balancing of oxygen, add water molecule to the oxygen deficient side. If you are having deficiency of 2 oxygen, add 2 water to that side. Other side will be automatically balanced depending upon the nature of the product produced. Now by this method, let us balance some of the reactions by ion electron method. So this is our oxalate ion combining with MnO4 negative in the presence of H positive ion to give you CO2 Mn2 positive plus water. Now in this case, write the oxidation number. Here carbon is in the plus 4 state, here it is in plus 3 state. So this will be our oxidation number increases by 1 per carbon. In this case, oxidation number decreases by 5 per manganese. So increase in oxidation number to be balanced with decrease in oxidation number. So how to balance it? Let us go for that. First of all, we'll be separating these two reactions. So first reaction will be the C2O4, two negative changes into 2CO2, and it loses electrons, 2 electrons. Here oxidation number of carbon was +3, it is in +4 state here. It is here +8 to carbon, it is here +6 to carbon. Then we have manganese. It is accepting 5 electrons in the presence of H positive ion becoming Mn2 positive. And if you add protons here, it will be having water also. Now it has accepted 5 electrons, but it has lost only 2 electrons. The number of lost and gained electrons, they should be equal. So multiply this equation by 5, this equation by 2. What we get? We get 5 oxalate ion plus electrons will be cancelled out, then H positive ions plus MnO4 negative ions. We have 10 CO2 plus 2 Mn2 positive plus water, that is 4H2O. That will be balanced later on. So now charges, they are being balanced, the half reactions, they are being balanced. Now you can balance hydrogen here. Here we were having 4 oxygen, multiply here with 4, add 8 here. And manganese, here 2 Mn, it was 2 MnO4. It would have been 2, then we would have multiplied by 4, it would have been 8 again. So this is a now balanced equation. C, carbon is 10 here, 10 carbon here, oxygen 5, 4s are 20, and 8, 28, 4 oxygen here, 20 here, 28, manganese 2, 2 manganese. So this is a balanced equation. So this is half reaction method. The main reaction is split into two parts. One part is representing oxidation, another part is representing reduction. These two parts, they are balanced separately and are added together to get the balanced redox reaction. Now after doing this, we balance another reaction which we balanced earlier by oxidation number method. Now that reaction will be balanced by this method, and that is that reaction is taken in the volumetric analysis. It is the oxidation of ferrous ions by KMnO4 in the presence of acidic medium, that is sulfuric acid. So this is our second reaction. Fe2 positive ion combined with MnO4 negative in the presence of H positive to give you Fe3 positive ion, Mn2 positive ion, and water here. So in this case, iron is changing oxidation number. Let us bring it separately. This reaction is called as oxidation half reaction. It is losing 1 electron. Second reaction will be MnO4 plus 7 state to plus 2 state in the presence of protons. We get water here. This is reduction half reaction. To balance hydrogen, we add here 8. We are getting 4 water. Now it is gaining 5 electrons here, but here it is producing only 1 electron. Multiply this equation by 5. Now we have the balanced equation. We get 5 Fe2 positive plus MnO4 negative plus 8 H positive electrons, they are cancelled. Then we have 5 Fe3 positive, Mn2 positive plus 4H2O. This is our redox reaction. You see all the atoms, they are being balanced. Here we were having 4 oxygen and we are having 4 oxygen here. Mn is single, 5 Fe, 5 Fe3 positive, 8 proton. They have produced 4 water molecules. So this is the way how to balance the redox reactions. Number one by oxidation number method, second was ion electron method or half reaction method. In the next lecture, we will be taking up the electrochemical cells, fuel cells, commercial cells, and rusting of iron. That will be a little bit idea regarding that. Thank you very much.